Hello, and welcome to my session on Azure Data Explorer, specifically building a high-performance data stack on Microsoft Azure. I'm going to go through some of the capabilities of big data in general, the ADX platform on Azure, and how to build advanced features into your solution stack. So first, a little bit about me. My name is Richard Conway. I'm a founder and director of a cloud and data consultancy called Elasticloud. We're UK based, and we've been doing cloud and data analytics now for around about 7 years, although most of our work's been Azure for the last 10. Personally, I'm an Azure Most Valuable Professional and a Microsoft Regional Director. Elasticloud is a Microsoft Azure Gold Partner for cloud platform and data platform analytics and security. And we were the OSS Partner of the Year for 2015, which is really part of our consciousness as a business. We're very much a group of open source contributors, and a lot of the software that I'll be talking about is backed by open source software. I love community. I co-founded the UK Azure User Group, which is one of the largest in Europe. The IoT and Data Science Innovators, Cloud Infrastructure User Group and Data Science London, and I run regular meetups and conferences with them. I've put back learnings into academy.microsoft.com and specifically the data science degree. Very much involved in teaching kids code. So I love teaching at Code Club, and correspondingly we've created a conference which we've been running since 2016 called Azure Craft UK, which is a fantastic conference that teaches children Minecraft programming, stuff about the cloud as well. We've done IoT too, but it's wonderful to see the kids learn, and we try and run this annually. Myself and my team are strong contributors to open source. Several Apache projects that you might know, like Storm, Spark, libcloud, and Parquet. Currently, we're 120 people and growing across London, Nottingham, Brazil, and Spain. So, subjects that we're going to cover in this talk. I'm going to introduce big data on Azure and some of the patterns that you may or may not be familiar with. Then I'm going to talk about ADX. From now on, we'll call this ADX. It's actually Azure Data Explorer. I'm going to give you a tour of ADX through the Azure portal, just to give you a flavor of what ADX looks like, all of the basic features, and how you can quick start with it. Then we're going to take a look at ADX through Custo Query Language, or KQL. And some of you may be familiar with this. Some of you may have used Log Analytics or App Insights, but not used ADX yet. These skills will be portable, you'll find, for ADX. I'm going to talk through an open source tool that I've been building, and would, as always, welcome contributions. And we're going to talk about how to ingest data into ADX and look at some of the advanced patterns that we can put into place. So let's start by talking about big data in general. So the first thing to say is data is getting bigger. Many organizations have ERPs, CRMs, and data was with these in megabytes. That's the volume of storage that we would have needed. But as time has gone on, we've moved into this era of Web 2.0, where we need to understand more of what's going on with our business environment, and that will include interaction of users from mobile platforms and web platforms, being able to check advertising feedback, collaboration, the search marketing, being able to build recommenders, weblog, so that we can know everything that our users are doing. With this, we're talking about terabytes of data. And then even though big data is more than volume, Now we're looking at petabytes effectively. So we'll see things like click streams, where users will have like hundreds of interactions, wikis, blogs online, sensor readings from IoT devices, social sentiment, so feeds from Twitter and Facebook, audio, video files, log files, location information, market data feeds on pricing and things like that, weather feeds, and text and images. And all of these things give us a need to store very, very large amounts of data. We've basically had this concept called the three V's for several years now, and that is the sort of populist definition of big data. We say velocity, variety, and volume, but there's many V's that have been added every single year. So you can see at the bottom we've also got veracity. So big data conjures up this idea of volume, but it doesn't necessarily follow that just because the big is in the title that it is that we're just talking about volume alone. We're also talking about the frequency that we get the data in. Normally up until the cloud era, we were dealing with data maybe once a day. We would have batch systems load up nightly data. Now we're talking about very, very comprehensive, what are called Lambda architectures, where we have a batch layer and a real-time layer, and we want to serve that data to our users at exactly the same time. The other thing is variety. So we have lots of different types of data, and that really personifies big data. And you'll find concepts like schema on read, which were popularized by Hadoop, which talk essentially about data where you don't know the schema in advance. You can infer it through code, you can infer it through config, but unlike a relational database with relations and normalization, you don't need to know this until the point of execution. So in terms of types, you have a lot of these, which is free text data. Then you have other things like append-only data. So append-only will be log files, essentially, where you don't specifically update any data. And these will be used to make new decisions daily. And also, you'll have more decision makers asking for more data over this time. We have this idea of KPIs and other things. And these are some of the questions that people might ask you when you're building a big data solution. So, why are visitors abandoning shopping carts? Who are my most dissatisfied users? Why aren't customers clicking on this content? What is impacting production daily? And so, we have to understand these things. And to be completely unbiased about this is a perfectly data-driven problem where we can discover behaviors and trends. We can understand patterns that might be very, very subtle and hidden. But if we have all this transactional data, it turns out that we can answer these questions. And the more successfully we answer these questions, generally the better business that we have. And you'll find the growth of e-commerce has typically been relying on answering these questions really well. So now that we've touched on big data, let's look at big data in Azure. And this is a very interesting slide. Again, some of you may have seen this before. This slide is called the modern data warehouse, and you'll tend to find that the majority of projects follow this track. We're going to go through this and we're going to talk through the steps. But as you can see, you have this idea of log files like unstructured data, and also business custom applications, things like ERP, CRMs, SAP. And one of the things that we do in our step one is we ingest this data into the cloud using Azure Data Factory, which is the cloud-based orchestration tool. And what we do is we land this data into Azure Data Lake Storage, and we'll have a specific landing zone for this storage. And we generally use Azure Databricks at this stage, or there's an inbuilt tool within Data Factory called Data Flow, which currently uses Databricks as well. And we can prep this data, and we can prep it in such a way that it's staged, so it's in a better form than the raw form that we land, which may have which may be a type aware form. So we might stage this in a form called Parquet, and then after we stage this, we might want to curate this. And to curate this, we might look at something like building the equivalent of of a set of views. And in step 4, we look at things like Azure Synapse Analytics, and this curated data, which we store back in our data lake, will tend to import into Synapse using Polybase, which is a fast way of importing data into Synapse Data Warehouse. But at this stage, it will probably be modeled. So we might have we might take this data. We want to slice and dice it, so we'll put this data in a form of facts and dimensions. If you've heard of things like Kimball models or star schemas, it's at this point that we'll have created that, and then we will take this data into Azure Analysis Services, which will allow us to create a tabular model and a set of KPIs which can be read by Power BI, and we'll serve this very, very fast to our users because Azure Analysis Services is an in-memory service, so it allows us to serve back through Power BI very quickly. We can also follow step 7, which is very much a Web 2.0 capability. So Azure Cosmos DB is a document DB. It's not schema bound, so we call this NoSQL. Unlike Synapse Analytics, where we'll have schema, we'll have relations, we'll have joins, these sorts of things. Our data in Cosmos DB will be presented as is, and that's what web applications like. It makes them much quicker. Whereas serving to Power BI, we'll want to slice and dice by date, which will mean that we'll need a date dimension and other things. So generally this is a fantastic framework, pattern and practice that you can do in the cloud, and it tends to work very, very well for most things. So if we look at what the platform architecture looks like, we'll pull data from APIs, we'll pull data from SQL, and you can see the key in the middle is this idea of Data Factory, which does an orchestration. And in our step 1, we'll use what's called a copy activity. It will pull the data as JSON into ADLS, into a restricted landing zone. And then, we may, in step 2, flatten this data. So JSON obviously is very can be nested, hierarchical, and we might want to do what's called denormalize it at this stage. Then later on, we'll be looking at transforming this data to a curation, load this into a star schema, into the SQL Data Warehouse, and then load into a tabular model. In step 4, we have a data catalog which connects to Power BI and will enable metadata discovery. And this is an important part of this, that generally this platform architecture, Microsoft's been working towards building governance controls over this for years, and this year there's the release of a new product which will help that immensely. And of course, we might want to secure this, put network boundaries around this, build in resource groups, so that we'll VNet enable all of this, and we'll ensure that only the protocols and only the IP addresses that need to go from one resource group to another or one subnet to another are bounded by network security groups, and concurrently we'll ensure that any keys are stored securely in an Azure Key Vault. And so, it's with this rapid availability of data that we can then begin to have use cases. So we have things like Azure Databricks, we have data science VMs and Azure Machine Learning. We also have things like Azure Search and SQL. And our data lake, as a result of this, then becomes our single version of the truth, with a lot of different capabilities sitting on top of it. And of course, you have sets of query interfaces, and these might be things like SQL, there might be things like Spark, there might be things like Jupyter Notebooks or Power BI. And so if we look at some of these patterns, just to go one level up, we'll see that we'll have logs, media, files, structured applications like SAP. We'll use things like Azure Databricks, we'll use things like Azure Data Factory to ingest and turn that data into something that's in a form that can be modeled very, very easily in Azure SQL Data Warehouse, or Azure Synapse as it's called now. But to a large extent, we use the data lake store as a buffer between the two, between the ingest and prep and the model and serve. So the data lake store has a life cycle, and we'll go through these landing, staging, and curated life cycles. Databricks have popularized a model which is bronze, silver, and gold, and we tend to use these in common language. And then lastly, we'll visualize this data in Power BI. But a level up, this is basically the patterns that we use for ingesting. And our common big data stores are file storage, so data lakes, huge volumes, but we have to be intelligent about how it's partitioned, wide tables ready for data science use cases, and we can use any language to read. Then concurrently, we've got our data warehouse, which we store data in, so Synapse, it's scalable, pausable SQL environment, and it's great for predefined workloads. Then we've got our NoSQL, which is Cosmos DB, which we've discussed, and also things like HBase on HD Insight, which scale incredibly well and allow us to do rapid reads and writes of semi-structured data. And these things are used for IoT, gaming, retail, anything that needs a very, very large data store that can be partitioned and accessed very easily. So now that we've touched on what happens with data in Azure, let's look at Azure Data Explorer. So Azure Data Explorer, or ADX, has effectively a whole bunch of things that it can take data from. So it can take data from Spark, ADF, applications can use the APIs. There's a framework called Logstash, which has a plugin which can send it logs. It can sync via Kafka, the IoT hub, the event hub. You can create event grid topics. And what this means is that you can both stream and batch data into Azure Data Explorer. And that's a very, very important consideration, because our classic Lambda architecture uses both streaming and batch to ingest data, and has a serving layer above those, so that as a user, as a consumer of this data, you'll be able to see both the streamed and the batch data. And that's incredibly important to make sure that you've got up-to-date data. And you can see that Azure Storage, or ADLS Gen 2, underpins all of this. And so what you have in Data Explorer is you have that ingest capability for stream and batch, but you also have a data management framework on top of this, and an engine. And one of the things that makes ADX incredibly powerful is that it's really quick. And it's really quick to query because it uses fast SSDs on virtual machines. So when we talk about ingesting, we may ingest from Azure Storage, from all these other sources, but what it will do is it will rewrite that data onto fast SSDs on virtual machines. And that means that we'll have things that are partitioned well, that that compute the virtual machines that underpin Azure Data Explorer, we'll be able to get really quickly. And so we've got control over this through the Azure portal, or we can use ARM templates and build apps and deployments of this. We can also use Azure Data Explorer in virtual networks. Then we've got command and control capabilities. So there's lots of different ways to access the data in this. We can use APIs, REST, SQL. In fact, in one of the projects that I've just been involved in, we've effectively built the equivalent of a security operations center, and it's ADX is responsible for indexing a lot of security data, and we've decided to write a web application. But we can build our own dashboards in ADX, so it allows dashboards through the UI. We can respond to events like flow logic apps. We can use ADF to pull data, to read data. We can use notebooks to interface directly. We've also created, using a Grafana plugin, the ability to create time series graphs, which is a fantastic way to look at data that's being updated through the day. So just to hone in on some of the real-time analytics pieces that you might want to do, and the sorts of ingestions, you may want to have things like ingesting IoT hub data, and you'll put Azure Stream Analytics in between this, so it will allow you to continuously stream that data in real time, and Azure Data Explorer will be able to take a source feed from that through event hubs, through something that's going to write to something that ADX can read, or Azure Data Explorer can read event hubs directly. So it has a capability where you tell it that you want an event hub, and it will just stream that data directly. The benefit is that you can do all of these things for apps and analytics. You can put data into a warehouse. You can train models, machine learning models. You can build real-time dashboards. You can alert apps. You can use Power Apps off of the back of this to build real-time triggers. And these are the sorts of data that most people will be ingesting. Business applications, weather data, customer sentiment data from social media, logs, files, media, and streaming data. And you may have seen different combinations of this in the past, but it's important to understand that there's a huge role for ADX in prepping this data, because it becomes very, very easy to write queries in Custo to shape the output of the data and the views so that you can effectively serve that data back to a data warehouse, and that will mean that you'll have those curated views that we've talked about, the sort of slice dimensions and the facts that you need to put into place so that you can have a really powerful visualization layer in BI. So we're going to touch on this idea of extents and ingestions. This is a fairly advanced topic from ADX, and we'll go through and we'll visualize some of this in some demos shortly. But you'll have things like Office 365 logs, and Office 365 logs are vast for some enterprise businesses. Huge amounts of data being generated by these logs, and if we want to be in a scenario where every single time we have one of these logs land in our data lake, what will happen is we'll have a creation date and we'll tag this. And it's an important consideration because we have two policies which are incredibly important when we ingest. We have this idea of an extent policy, which will keep all data in with certain column values in the same place. So it becomes an important consideration because we need to partition this data properly. This idea of having extents is a very, very important idea, because it means that we can concurrently write a lot of data that's coming in to different parts of ADX. So we have like much faster writes and automatic indexing. And you can see in the diagram here that we have partitions 1, 2, 3, 4, and 5, and this is based on the idea that as we have raw data coming in, it triggers a policy, an update policy, and that update policy will say, let's tag this data with a timestamp so that we know when it's come in, and we'll use a column through what's called an extent policy when this is written to the raw incoming table, and that will partition this in a way that will make it easily readable when we read back. So we'll have fast writes as a result, and we'll have fast reads when we read back, because it will be nicely partitioned by column. I'm just going to talk about another capability, and I'm also going to describe this and show you how this actually works in a demo later on. But this is incredibly powerful. It's quite a hard thing to do in big data as well. It's been a feature of Azure Synapse for a long time now, and SQLDB, where you'll be allowed to have role-level security, and you'll be able to use Azure Active Directory groups to be able to manage this security. So you can see here that we've applied a simple function, and you can see this function just says mask credit card data for support reps. And what this is doing is it's checking to see whether we're in a particular Azure Active Directory group, and then it's writing out two queries or two views on the basis of that group. And you'll find in ADX that as we create a table, a policy will be applied to a table, and you'll have many policies applied to a table. We've talked about update policies and extant policies, and also row-level security policies like this, which will allow us to mask credit card data as it comes in. So if we switch over now to our demos, let's start with a tour of ADX, and I'm just going to show you how you can create a cluster, and I'm going to show you an existing cluster as it appears, because I'm going to do all of my demos through that. And everything that you see here you can read on my blog, which is at aizoo.info. Okay, so I'm going to take you to my ADX cluster, and I'm going to walk you through this just so that you understand all of the features of Azure Data Explorer. So as you can see here, on my particular cluster, we have a URI, which is our endpoint, and we also have a data ingestion URI. And you'll see this one in particular is just a dev cluster with a single instance count. It's relatively cheap. If you want to get up and running and you want to do this within your MSDN subscription, you can have a dev cluster and you can run this through monthly every month, and you can do all of the exercises and learnings that I'm showing you here. So the URI is the actual endpoint of this. This is where you get to this on the web. So in my case, I've created a cluster, ectestcluster.northeurope.custo.windows.net. But I've also got a data ingestion URI, and this is where I can use tools to fast ingest data into my cluster. And it's worth mentioning that all of this can run in a VNet as well, which means that you can secure this behind network boundaries, and you'll find that you have private IP addresses for each of these. Then, as you see on the home page, we have a series of databases. So I've created 3 databases here, and by default they're all read-write. We have a retention period for this, so the data specifically could be purged after a certain time. We also have what's called a cache period, and this cache period by default is 31 days, and that's also important because what that does is all of the most recent queries I should be able to work out how effective those are by building up a stock cache of queries that can be rerun over and over again. And so the default for this is 31 days. Then you'll obviously see that you have your default IAM. This is important and worth mentioning because there are certain aspects of using service principals where you'll need to understand this and add these IAMs for the full command and control. You'll see that you have permissions, so I can add new users here in specific roles. So we've got admin roles and we've got reader roles, and I can as you can see, I can add both both users and apps. App being an app registration as service principal here. Correspondingly, we've got this query interface, and let's wait for it to render. And you can see that we've got like a master database here, which I can run some queries under. But what I'm going to do is I'm going to open up the web API. It will ask me to sign in, and you can see that I can see all of my databases here. And I should be able to run some queries. So for example, let me just do a quick query, and you can see that in this web UI I get this beautiful IntelliSense, and even on commands, and I can run that, and there you go, and I get a bunch of data back. So that's fantastic. I can use all of this through the web. Now if we go back to here, there's a couple of other things that are incredibly important. You have the ability to scale up, so I can create bigger VMs, and obviously the more data that I have, the more VMs I have, and you'll find that you have the bigger the VMs, the more VMs you have slots for things like ingestion and other things. So the more data you ingest, the more data you read, the more data you write, you'll need more capability and more scale. And this will give you the slots as you scale up. And you can also scale out as well. So I'm only running a dev instance here, but we can use manual scaling. I can auto scale. There's like my own auto scale algorithm, or Microsoft provide one now. So it makes it very, very easy for me to think about that. Then we've got our basic configurations. You can see that I've got two things enabled here. We've got streaming ingestion, which allows me to stream in Event Hub messages, purge, which allows me to delete data from each table, because by default that's not allowed, and Python and R language support, which I haven't enabled. Consequently, I've also got a system assigned managed identity as well. So ADX can be that capability, and it will have its own identity, which then allows it to query things like the Azure Key Vault and other things as ADX, and so on and so forth. There's a lot of other services around metrics, security, logs. I can automate this, and I can get another view of the databases as well. And we can go into each of these databases, we can query on them, and we'll be looking shortly at some of the features here regarding data ingestion. Okay, so now we've had a run through of this. What I'm going to do is I'm going to show you my favorite tool, which is Azure Data Explorer, and we will shortly see here. Now I have, I'm going to take you through the first thing that you will learn with Custo Query Language. So I've created a table called sales, and if you look in the connection here, we have our sales database, here, and you can see that I've got all of the columns and they're all typed already. Okay, so so this is Custo, and there we go. And so it's given me a set of sales data, and these are the raw line items. We get region, country, the item type, sales channel, order priority, the order date, order ID, all of these things, units sold, revenue, exactly. I can also change this. You can see here, limit, and I get in this Custo Explorer, which is my favorite tool for querying, we get, you can see that occurred much faster because the query was cached. So let's count by using count, and you can see that we've got 500,000 rows in this sales table. Now just to round this off, you can see this as well. You can go to aizoo.info and you can learn about all of the you can learn to get the data from all of the public sources that I used, and you can see all these queries on aizoo.info as well if you want to replicate them. So let's take this first thing, and we can use this very much like SQL Server Management Studio. So this is just taking the sales table and it's projecting all of these out across the 500,000 rows. So you can see we've just taken these, and we'll have, like, it doesn't really tell us very much because we'll have multiple counts of Europe. We're just restricting this. But then, so project is very much like a select in SQL. And then we have a summarize operator, which is like a group by, and we can define things like earnings. So here, I'm rounding total revenue. I'm turning it into, let me see. So I'm turning that into billions. And I'm summarizing the earnings by region and by year. Okay, so we can run that and we'll get the equivalent of a SQL group by, and you can see that was pretty quick there. And lastly, we can take those sales, and you can see here that we get by year each of the particular earnings. Okay. We're going to go on to something a little more advanced, and this is the same query that we just saw. So let's run that again, and we should see that really quickly because it was cached. Let's just show that a little bit more on the screen. And yeah, you can see here we get that. So if we run that, we should see a column chart. So you can see that I've got a legend here, Asia earnings, Oceania earnings, Caribbean earnings, and I can go over these. I can roll over these, and you can see that they give me the actual values. But it's really easy to learn this, and you can see this is by year, and we can make some inferences that the data maybe only goes up to 2017 and maybe only halfway through 2017 because we've got half the amount of bars. But you know, there's lots of different charts that we can use with the render command. So I can change this, for example, to a line chart, and let's run it again. And you see we get that line chart. It's fairly flat, so there's not much change in earnings between year to year between all of these continents, but you could see how easy it was for me to manipulate and put that together. So let's carry on and do something a little bit more advanced. This is effectively taking what we've just done and turning this into what's called a function. So we've taken our sales table, we project our country, we take our total profit, we turn that into just a column called profit, and that's profit equals. It's like an alias or an as in SQL. And then we create our earnings, then we create our year. So if we run that, let's wait a few seconds to get a result. Yeah, you can see. And then we'll summarize this as well. So we'll get our earnings, our profit, our transaction count per year, the number of transactions that we've done, and do sum everything by year. So if we run that, we get that pretty quickly, and we might then want to order that. You can see here that it's ordered, and that's ordered descending by default. The year would be ascending, as you can see, and then we use the extend command to add a column, so earnings. So let's do that, and you can see we've got this earnings ratio, which works out the ratio between our profit and our earnings. Okay, and gives it to us as a percentage, 28.81%. Now we wrap this up into a create function if none exists, and give it a description, and we call this function all country summary state. So let's run this, and lo and behold, we've now got a function with no parameters, you can see, and every single time we call that function, it will run that Custo query. So one of the things that Custo has is it has these commands to show various things. So we'll start with show databases here. So you can see that we've got databases, we've got where the actual storage is. By default, it creates and stores these databases in a blob storage account. So you can see the endpoints here, and you can see I've got 3 databases: master, another DB, and solo. I can show capacities here, and I talked about the ability to have slots. So you can see I've only got one slot to ingest, to merge, to purge, to export, stream, and to do queries. So it's important to understand that with the dev capability, it's quite limited. Then here I can show the cache. So you can see the memory that it has, the cache that's in use, and all of these stats. And you'll find that these commands should be used quite frequently. They tell you a whole load of things about the state of the ADX cluster, and you can see as well that I can see who has access to my sales table. I've got users. Some of them are inherited, so I'm a database master admin, I'm a all databases admin, and I'm also added on sales. And we've got our app ADX, and some of these are inherited down from other places. So let's take a look, and you'll see we're using the let keyword here. So one of the reasons I wanted to show this is because one of the keys that you'll find is that ADX is fantastic at doing time series things, and Custo's got a lot of language features built in for time series. So we're going to start this now, and you can see that there's a summarized query here on sales, and we're just going to get January 2010 sales, and then we've got like a min and a max on the timestamp, and then we call this function here called make series, and that will turn this into a time series based on the min and the max and 1 day, and then summarize this by region, and then render this thing called a time chart. So let's take a look at that. Okay, and you can see that that's giving us the temporal behavior in January for all of the sales per day. Okay, and this is our starting point for a whole load of stuff that we can do with regard to forecasting. And we can use ORs, we can use ANDs, we can use all kinds of things in our queries as well, and we'll find that we can enhance this to okay, so the demo gods weren't favorable to me here, so I've got something wrong with my where clause, but let's not worry about that now. what this should have done is it should have created a time series over 3 months, and you'll see here, just to explain some of these things, where I call make series and default, any values that are missing on a particular day, it will then say that that on this particular day and I've just seen this. Let's try that. Right, it will then say that on this particular day, substitute this value with 0. Substituting things by 0, or imputing as it's called, isn't always the best thing to do, but in this instance we're doing it because it's simple. So let's try again. And now it seems to work. So we've got a lot more data there, and you can see now we've got this sort of 3-month spread showing country by country. We've limited this to Canada, France, and the United Kingdom. So that's another example of how to do a more complex query. Okay, and this, one of the things that this does is it creates better time series and better forecasting using these series for functions. So in this case, let's run this query again, and I will explain what this is doing. But using series for, you can see that we've managed to show the trend here. So, it's not a hugely great trend because some of the peaks are high, but what this is doing is it's effectively taking like a rolling average, if you like, and I tell this to take every single 8 periods over the number of items sold, number of units sold here, across the time series. So we can shrink this, we can make this 5, and let's see what changes that occur there. You can see it's slightly better, and we can play around with these numbers on the moving average. And similarly, we can, which is very common with time series, we can split this into our actual series and the residuals. So we can understand that we have different parts of this time series where we have a lot of noise, which is our sort of random activity, which we're trying to predict, and we have our trend. Okay, so when we subtract the two, they should add up to the actual number sold. Okay, so this is a way of what we call decomposing our time series. Fantastic. So one of the things that we're going to move on now, and one of the things that I'm going to show you is how to ingest data. So to do this, I'm going to go back to the portal. We're going to try this, and we're going to see whether we can add another database. And I'm going to call this database DPS days. And you can see I can choose the retention and caching period. So let's create that. Fantastic. So we've got our DPS days here, and I'm going to start by ingesting some data. So let's click on this, and we'll go to our query interface again, and we'll open in Web UI. You can see it's asking me to sign in, as always, and let's refresh that. Okay, so we've got our DPS days, and one of the things that I'm going to do is click on ingest new data. So it's asking me to select a table. I'm going to create a new table, and I'm going to call this table weather. Oh, in fact, we're calling this plant data even. Okay, and rather than from blob, I'm going to get this from a file. So let me take these plant generation data. I write about this, so you can see this on my site. We can get this data from Kaggle. So you probably noticed that this data was zipped as well. So we're going to edit schema, and automatically you can see that it's done this mapping. So if I click includes column names, then by default you'll see that we've got date times, plant IDs, all of these things, right? And it's picked out the numbers correctly, it's picked out the source strings, plant IDs, hasn't quite picked out the date time, but let's not worry about that yet. So it also creates a mapping to the table itself. So let's click on Start Ingestion, and it will ingest this, and we can now go back to our Custo Explorer, and we'll create a new tab. In fact, I'm just gonna create it from our connections. Refresh here. It's DPS days. Let's click on that and new tab. Okay, and you can see that it's DPS days, so we should have plant data. Let's limit that to 200. Let's run that, and we've got our plant data there. And correspondingly, we're going to have, let's just find out how much data we've actually got. So we'll count that data, and we've got 71,960 rows. Fantastic. Okay. So then what I'm going to do is I've created a new container called DPS, and I'm going to create something called plant data. Yes, so plant data, and we are going to look at how we can do ingestion, and we should be able to see quite quickly that we've got a really powerful capability here. So I'm going to add a data connection, and I'm going to point it towards blob storage. I'm going to call this plant data, and I want to go to ECADX, and I'm going to pick on blob created, and we'll see these things. So we've got default containers, and then the container name I think is DPS days. Let's double check that again. It's just DPS, okay? And then we've got a folder called plant data. Okay, so we've got DPS, then we've got blobs, plant data, and suffix. I think we've got a zip file here, so let's choose that, and we'll choose our table name, which is plant data, format, which is, I think it's actually CSV, and our mapping name, can't quite remember the mapping name, so here's a good opportunity to go back and to show table plant data ingestion CSV mappings. So let's run that, and it's called plant data underscore mappings. Plant data underscore mappings, and so we'll review and create that, and let's go and create that. So what that's doing is it is creating an event grid topic, and every single time a file is put into the plant data folder, it should then automatically generate an event which will be fired, which ADX will pick up, and then ADX will read that file, and it will parse that file, and then it will take that file specifically through its particular process, which will be, in this case, ingesting it. Now that's almost finished, it seems. The reason I want to wait for this to finish is because, that's a shame. We'll take a look at that later. It may be that we could redeploy that and it works. There's obviously some kind of conflict there with the connections. Maybe I've misnamed this and named it as plant. Maybe plant data already exists. Unfortunately, I think that's the problem. Okay. So then one of the things which I'll do is just flip over just to show you on the other database. What I did was I ingested this. Let me see. I don't think this is actually bound. Yes. Okay. So let's look at our connections. We'll go to solar. We'll go to weather and open a new tab. Perfect. Let's just copy this across to the new tab, and then it will help me go through this and iterate. So let's look here, and we've got our weather data. We've also got, I called the data, the plant data generation data in my solar database. So one of the things that you can do is effectively join on these two, weather data and generation data. Okay. One of the things that I wanted to show was this idea of an update function. So we've seen us create tables in a certain way, and creating tables through the ingestion is one thing, but then also creating tables in this way through specifically through KQL. You just use the .create command. And then for every table, you can apply an update policy. So in the case of the weather table, and in the case of the generation table, which I wanted to put together and make them time bound, we have a query which does the project, which you've seen, but it also does a join. So it does an inner join between weather, and we use these things. So .left and .right. And then we can just reproject this out. Let's take a look, see if this query can work. And yeah, you can see that it can work. It doesn't always have the total yield values for these dates, because some of them might be empty. But what will happen with an update function is that every single time we have records that are put into our generation table, it will trigger this update function. And you can see here that to put an update function, it's like a trigger in SQL. We do alter table, and then I've created my table above, weather generation, policy update, and then we put the source table, which is generation, we put our query here, and we propagate all of our properties. And it's literally that simple. So we'll have date every time we put data for a new plant into the generation table, it will also appear using this joined query from weather into the weather generation table. So it becomes very, very powerful in that you can automatically create views from this. So I wanted to just show you one last thing. There's a very popular site, generatedata.com, and I've used that to create credit card data. And you can see here that we've got that I can see all of this data. Okay, so one of the things that that we can do here is use row-level security that I described earlier, and we do this through a function. So you can see I've called my function create RLS for credit cards. I've checked to see whether I'm a member. I can use either a user or a group, and then I can I'm using my username here in this case, and I can say can see all. Okay, and you can see that if I can't see all, I'll have a partial query where I just use stars here and get the last 4 characters in the substring for this, and then project this back out, and you can see I use the filter condition here and I use the filter condition here. Okay, so now you can see that I can see all, right? But what I'm going to do is I'm going to change this to Andy, who's also a member of the Elastic Cloud AAD, and I'm going to update this function, this row-level function, and you can see that I've updated the function. I don't need to reattach this. So here, alt table credit cards. But what I am going to do is just run this query again. Oops. Let's try query here. Doesn't seem to have been able to show that. So let's try to bind the policy again. And it doesn't seem to have liked that at all. What we were expecting was the ability to take this credit card data, and we can still try that one last time on the master database. I think we've lost our context. So let's just try that again. And yeah, okay. Now you can see there. So in our function, you can see that I changed over from my name, so to Andy's name. Let me change it back again. Okay, so back to Richard, which is my email. Let's run that again, and let's search again, and I can see everything. One last time to prove that it's working. Oops. Not sure I actually executed that. Okay. Anyway, I think you got the gist of it, and you could see that that flipping between these states was okay. Flipping between these states actually worked. Maybe there's a little bit of latency there. I'm not quite sure. So I wanted to just draw your attention to one of the things that I've been working on, which is a tool called dex command. And dex command allows you to do a few things. I'm going to add more things to it, but it uses either your own AAD, so it will give you a prompt for a web browser, and you can use the command line to list databases, list the tables within that, and also to add users. So it's very much like a quick command that you can use if you're supporting an Azure Data Explorer cluster. In summary, and I just wanted to take you through the demo pieces whilst we're here. So the ingesting data, we would create the table, create the mapping of the table from the source data to the table. We create the ingestion, We create our query to join weather and generation. We create the data connection. We set the blob path, and we check if we were ingesting this in real time. We would check that the update had actually ingested that. Of course, we had a conflict in our example, but had we not had that conflict, I would have been able to take that file, put it into storage, and then that data would just have miraculously appeared in the table. Update function, similar process, but you see that there's line 3 which says that we would create a join between that table and something else, build that join function, and take that as an update function, an update policy which we would apply to the source table, so generation in this case, and then we would put generation and weather together to become generation weather, which is a new table every single time we had generation data. So very, very powerful stuff. We looked at row level security. Some of the advanced features that we haven't covered in this are things like windowing functions, which you might have come across, which allow us to window behavior and apply functions over sliding windows and time periods, materialize views, partitions. Out of the box, we can have the ADX UI give us a set of dashboards, and we can also have regular expressions and array manipulations, which is something that I've been doing quite a lot of with our Security Operations Center view. Just to say a special thank you for Microsoft for supporting Data Platform Geeks and SQL Server Geeks and all the community initiatives. And thank you again. There's 3 ways to win prizes. So post your selfie with a hashtag to #DPS2020. Give us some session and conference feedback. Visit our sponsors and exhibitors rooms, and follow us all on Twitter on at the Data Geeks and at Data AI Summit. Thank you very much for listening.